Hello, boys and girls. The winners for Biology Science Demo was released just this morning. We are now heading into our next science demo session for PISF 2021, which is Physics Science Demo. As usual, we will start with STEM speaker session today and continue with the live demo this Thursday. Remember, you will have to tune in to both our STEM speaker and live demo session to participate in our quiz. Make sure you do that so that you can win exciting prizes. Today, our guest speaker Ilyani will be sharing with us a little about semiconductors and circuits. As we go through today's session together, do share your thoughts about the new things Ilyani is sharing. You can use the comment section to do this. So let's learn about semiconductors and circuits together. Ilyani, the virtual stage is yours.
Hi, thanks, Aili. Hi, everyone. Okay, I'm Nur Ilyani binti Muhammad Lena, and I go by Yani. So today, I will be sharing a little bit about semiconductors, and then I will tie a bit with the well-known basic circuitry. I will introduce what is the semiconductors, how we integrate Ohm's law into basic circuitry, and I will close with some applications and contribution example from semiconductors industry. Hope you guys enjoy it. Okay, so what is semiconductors? So you might heard of diodes, transistors, integrated circuit IC, or as well known as the microchips. So these are the examples of the semiconductors applications. Then what is the semiconductors? So as a name of itself, it can do both. It can conduct and it can also insulate. So whether it can conduct or insulate, it depends on the electron that moves around from one place to another that creates the current flow. So as you can see from this simple diagram, so you can see that this element has 4 valence electrons. So from this valence electron, we know that it is held by the chemical bond. So if we have enough energy applied to this element, it will break this bond, and then this electron will move around. So when it moves, it will create an empty space, which is what we call as holes. So from this, the neighboring electron will repeat the same movement. So the exchange of the electron from one place to another will create the current flow. Just now I show you that the element has 4 valence electron, right? So we know 4 valence electron, the element mass coming from the group 14. So the most famous group 14 is the silicon, the germanium, and stannum, or what we call as tin. So this is the elements that widely being used in semiconductors. Of course, like having this group 14 alone is not efficient enough. So scientists come up with the with like adding more extra holes or extra electron, which will increase the performance of the semiconductors itself. So that is what we call as a doping agent. Okay, so for the doping agent, we will use group 13 and also group 15 elements. So group 13 is the boron and aluminum, and from the group 15 is the phosphorus and arsenic. So as you know, group 13 is lacking 1 valence electron to be stable, and group 15 is having 1 extra electron to be stable. So I do not have much time today to explain the doping mechanism, so I will leave this info for you to do more research on your own, okay? Right, now you have the elements, you know how it works, and then we need to know how we want to integrate this information into a workable and usable system for the humans. So I want to remind you about the most well-known Ohm's law, which is the first electrical law that all of us learn. So when I say Ohm's law, I believe that V equals to IR is the first formula that comes from into your mind, right? So from this simple formula, we learn more complex formulas. So I won't be touching those info today. So because I believe that you guys learn a lot in this like daily classes, right? So V equals to IR. V is the voltage, I is the current, and R is the resistance. So from this basic law, scientists introduce us two simple circuitries, which is the series and also parallel circuit. So how these two differentiate is how the VIR works together. So I will just take example for the voltage today. So for voltage, so you see in the series circuit, the total of the voltage will be the sum of all the voltage in this loop. So say that you have um, V1, V2, and V3. So voltage one is 1 volt, and 1 volt each. The total of the voltage will be 3 volt. Okay, but compared to the parallel circuit, say that you have three loads here. So if you the source is 3 volt, V1, V2, and V3 will have the same voltage amount, which is also 3 volt. Okay. So how we use series and parallel, it depends on the applications that we want lah. Okay, so that's why in our home wiring we often use the parallel circuit because we want to optimize the applications. And then in our water heating system, we use series circuit because we want to enhance the safety. Okay, so as I said, like it's either parallel or series circuit. It depends on how you want to use it. So sometimes you will see capacitors is assembled in parallel, and sometimes it is assembled in series. So this is one of the commonly used component in our industry. So which is the capacitors. So what is the functions of the capacitors? So yeah, we will use capacitors to store the energy. So let's go to the circuit for the capacitor itself. So the mechanism for the capacitance will be the opposite of the resistance. So if you take a look back the resistance formula that I showed just now, you will see that they are opposite. So just take example for the parallel circuit today for the capacitor. So you will see that from this example, so each of this capacitor, this one is 0.1 microfarad, 0.2 microfarad, 0.3 microfarad. So the total capacitance that we managed to come up with is 0.6 microfarad. Farad is the unit for the capacitance itself, okay? So in conclusion, if we put the capacitor in parallel circuit, we will achieve more higher total capacitance. So if we have more total capacitance, we will be able to store more energy. All right, so I want to introduce, like, give a real life example on how we use the capacitors. So capacitors work like a energy bank. So say that, for example, you have your laptop, and suddenly your laptop power off, that shut down totally. So like we have the capacitor banks in our laptop. So this energy stored in this capacitor will be used to save all your unsafe work because we don't want to have any data loss. So that is where we make use of the capacitor to improve our integrity in our products. So in this industry, there is no one finite answer on how we contribute to human races because engineering and technology covers all areas that we can think of. You might not see it true, but in this COVID-19 pandemic, this industry skyrocket as there is so much demand in every area, be it in medical, in education, transportations, entertainment, and so on. So I believe like all of us know how important the ventilators is in this pandemic for the COVID-19 patient, right? So in these mechanical ventilators, it has semiconductor sensors. Okay, so these sensors will collect all the signal and data from the patient breathing pattern. So from the data that collected, it will transfer back to the semiconductors microprocessors. So it will process the data and then will determine what is the output needed for this patient. So the data includes like the oxygen and carbon dioxide level and also the breathing patterns. That is just an example. There should be much more data collected from this data transfer and data collection. And then this determined output is then translated into the mechanized breathing so that the patients can breathe at the optimum level. So in a way that this machine help to regulate the breathing pattern for this passion lah, basically. So, like, who create this machine? Definitely from the combinations of great minds, which includes the engineers and also the designers. To sum up my sharing today, I can tell that semiconductors industry will be among the leaders for our future technologies. From a special element, silicon and germanium, for example, scientists and engineers give a massive contributions to the world. So despite all of these fancy technologies, it all started with our basic knowledge of the circuitry that derives from the first electrical law that we learned, which is the Ohm's law. So if you are interested to be among the great minds, all you need to do is just to start, be it in the physics or in engineering field. I might have talked a lot about the engineering field, but let me introduce myself as a person who never wants to become an engineer in the first place. All right. So I'm currently working as a SSD product engineer in Micron Memory Penang. So I will be celebrating my second anniversary next month. Okay. So what do I actually do? So I basically need to make sure that the products that I own is running smoothly in the production floor. And then I will need to provide all supports to other department whenever needed. So to be in this position, I am expected to know mostly everything from A to Z. But yeah, it's quite challenging. But I always see challenge as an opportunity to do much more improvement. Okay, as I said earlier, I never imagined myself to be in this fancy technical field. Back in high school, my favorite subject is, yeah, you bet, it's biology. I am in a pure science stream, so engineering is nowhere to be seen. And yes, physics is my least favorite subject during SPM. So in biology, my favorite topic is the respiratory system. So back then, to write an essay, to write an biology essay about how respiratory system works, it's like a piece of cake. But yeah, don't ask me now because I already left this subject at least 8 years ago. Right. I did my degree at the Ohio State University. Yes, Ohio. It's not Japan. It's in the Columbus, Ohio, USA. So I graduated in 2019 in electrical and computer engineering with cum laude honors, and my focus was in SSD. Okay, before I pursue my studies in electrical engineering, it's not like I directly go to electrical engineering. I had a taste of medical school first. Like it is a norm, all of us, the Asian kids, like smart kids, must be a doctor, right? So yeah, I managed to enroll in medical school, but only for 1 month before I got this opportunity and shift to engineering. So yeah, this is my first wild card. White card. Like I don't know how am I going to do in engineering because I never liked physics. All I all I know is like biology, like all the science. Yeah, all the biology stuff. So I started as a mechanical engineering student. Okay, meaning when I flew to USA, I was determined to get an mechanical engineering degree, per se. But due to some constraint, I changed my degree to electrical engineering in my second semester. So I have no idea if I can survive in this electrical engineering, but screw it. I'm taking the challenge. But finally, I still managed to successfully graduate with in electrical engineering, and I am now already an engineer in this field. I think like the main reason why I managed to go through all these hurdles is because I always believe in myself, and you should too. Have courage to explore, as you can't confirm what you have today to stay with you forever. So technology is like everywhere, and definitely there is so much more room for improvement and for innovations. So lastly, I just want to emphasize that we should normalize to break the norm and be able to explore our passion. Honestly, I am so glad that I chose engineering, and I am looking forward to explore like different areas for my future careers. Yeah, that's all for me. Back to you, Ailey.
Thank you for sharing your knowledge, Ilyani. I think for me, at this point, I especially love how you shared your experiences as a student before becoming an engineer. Because I remember myself how, as a Form 5 student, choosing what to study, what to do as a grown up was such a huge, daunting decision to make at the time, right? And I think it's great to have role models like you to remind our students that it's okay to change our minds sometimes and find out more about what we love and what we are good at and what's important to us along the way. So, boys and girls, we hope you learned something new about semiconductors and circuits today. During the science demo this Thursday, we will learn even more about semiconductors. My colleague will demonstrate how rectifier circuits are built using multisim. So do tune in. You can collect hints from these two sessions, okay? Today's session as well as Thursday's session as well, and join the quiz to win exciting prizes. The quiz will open after the session on Thursday, so make sure you stay tuned to the link, okay? It will only be released after the session on Thursday. So thank you guys for joining us. We'll see you in the next session. Bye.